air filter of the gas turbine. You replace it when you have high delta B. That means it's partially or start to be blocked. At certain time, it gives you an alarm that you have now warning about high pressure difference on the filter. That means this filter is blocked now. You need to replace. Then the nature of this part is run to fail. Then if we see here the curve representing the life or the capability of this part, starting from high capability up to this point. This part is no longer capable to provide the function it's designed for. After that, it's considered as failed. We have two types of failure actually: function failure and performance failure. Function failure, that means the equipment is not capable to give this function anymore. And performance failure, that means the function is not performing as expected anymore. Like as example we said about the filter is performance failure. Yeah, it's still working, but it's not performing as expected. If it keep running like this, it will make big problem or make catastrophic failure. So you need to take action to replace it. What the mean of preventive maintenance? Preventive maintenance has many names, like time-based maintenance, periodic maintenance, preventive maintenance, of course. Then it count on certain time, like at certain time you need to do certain kind or certain types of activity or maintenance activity. Then when exactly I get this preventive maintenance procedure or steps, I can get it from many ways. First is from the manufacturer. The manufacturer himself, he gives me this instruction. Like for gas turbine or for other machines, it counted as operating running hours. After certain running hours, you have to do this kind of maintenance, like for gas turbine also, because it's a major one and we all have in our plants gas turbines. After 12,000 running hours, you need to do like hot gas pulse inspection. After 24, you have to do the same, maybe boroscope inspection for each 6,000, and also you can do this another hot gas pulse. And after 45 or 50, depend on the turbine type, you need to make complete or overall maintenance, like replacing a lot of parts. Every time you do this kind of maintenance, you need to get yourself ready for this by providing or to supplying the proper resources, the proper manpower, the proper tools, everything like this. But the point here, let's understand exactly why this preventive maintenance time-based and what the concept here. The concept here is come in this curve, and we call it a bathtub curve. What this bathtub curve represent? It's actually presenting the process starting from equipment start to end or to complete failure. And we found here that at the beginning, the probability of failure, or what we call it hazard rate here, is high, very high. Why it's high at the beginning? Especially this equipment is brand new and we just install it and everything should be fine. But we found here that the hazard rate is high and the probability of failure is high. Why is that? Because many reasons. Like first, you may have something wrong in installation. You may have anything wrong in design phase, and you can find it here in the beginning due to error, human error due to operation. Also, the probability of this failure is high. Then anything can happen at the beginning which lead the machine to fail. That's why we call it infant mortality. That means the failure at the beginning of its life. After that, and after we finish, we solve all of the issues at the beginning, we found that the rate is coming at very low percentage here, and that's what we call as the useful life. then the equipment is running at this level of hazard, which is low, after we solving all the starting issues here. And finally, after this time, we found the failure start due to wear out, or the fatigue. What the mean of fatigue? Fatigue, that means this part or this equipment get tired from operation, and the fatigue represented in cracks. Once you find the crack, that means this part is exposed to fatigue, to repeated stresses. And this stress could be mechanical stress, could be heat stress, could be any kind of stressing. Like in some kind of operation, we found like in dehydration package, we found that heating, cooling. In this case, we found that this part or this components part exposing to heating, which make expansion, cooling, retraction, and so on. This repetition make fatigue, and of course it will lead to crack in the machine parts. Okay, then the failures at the beginning here is related to quality failure. It's according to quality of installation, quality of the equipment, quality of design. All of these quality issues, failure can be found here at this stage, at the early stage. But if we talk about wear out and failure and cracks, fatigues, all of this, it happened at the end of the equipment life or spare part life. Then this curve representing all the life for spare parts, for machine, even for human, the same. Then finally, we come to predictive maintenance. What is predictive maintenance concept? Predictive maintenance, from its name, to predict the failure before it happened. And this could be decrease planning maintenance, of course, and decreasing surface loss, lowering the risk, improving the workforce, asset availability and reliability, of course, recovering revenues, because it increase revenues because you don't need to stop the machine every time to doing BM, to doing corrective maintenance, or to run to fail. You can detect the failure before it happens, so you have enough time to make your preparation. That's why predictive maintenance is the very important one, and actually this is the main concept or the main core of our course. Then, when this predictive maintenance predicting the failure, this curve representing the normal life here, and the failure starting at this point. When the failure start, equipment health, like here at the y-axis here, start to going down or decrease. At this early stage, we can using the predictive techniques and go after that to the end. Then we are in predictive maintenance, we are focused in this area, but here we are focused on preventive area. Here reactive, that means the failure is almost happened or become very obvious. But the point here that when you detect the failure in early stage, like in predictive, the maintenance cost will be less than you doing preventive maintenance, or you are doing the corrective maintenance or run to fail concept here when the machine completely failed. Because if you count on the complete machinery failure like run to fail techniques, you could lose all the machine. That's why we are looking for predictive techniques to detect the failure before happen or in very early stage. Like what? Condition monitoring techniques have many techniques, like vibration analysis, of course, with the main core, the ultrasound technique, the infrathermography, the oil analysis. All these techniques is predicting the failure in very early stage with different means. Then